Good morning, everyone. Thank you for being here. We're going to go ahead and get started. If anyone jumps on after we get started, we'll just welcome them and keep going. So I'm Natalie Cruz from Ohio University, and I'm just going to set us up for the day, and then I'm going to hand it over to Rebecca Steinberg, who is one of our master's students in environmental studies who has been responsible for programming and coding the tool that we're demonstrating to you today. So I know a lot of you were on our webinar a couple of weeks ago where we introduced the theory and the development of this tool. But I just want to set everyone up with, we worked with the data from underground mines, from post-Smacra underground mines in Ohio to develop empirical relationships between information about those mines and water level. We then program that into a ArcGIS tool that can automatically run through those empirical relationships and output a predicted post-mining water level. So if anyone's interested in the development of those equations or what that all looks like and what all the testing has looked like, we will post the recording from the previous webinar on the project website. And we'll send that out to everybody. It's a page on watersheddata.com, but we'll send a direct link out to everybody who's interested. So without further ado, I'm going to pass it over to Rebecca Steinberg, who is, like I said, one of our students, and she'll walk you through the tool. If anyone has any questions, please type them into the chat box and we'll address them either I'll type back a response or we'll respond at the end. Mm-hmm. Okay, so here's Becca.
Good morning, everyone. I'm Rebecca. I hope everyone can hear me all right. Okay, yeah, that'll help. All right, so jumping right in.
Yeah, can everybody just type in if you can hear okay? Just let us know that you can all hear us in the chat box real quick if you can hear. Thank you.
Everyone's typing. Okay, so we wanted to start out once again with a special thanks to all of our sponsors for this project. Yeah, there we go. Can you hear? Great. Thank you. And also, Dr. Cruz already gave you a little bit of a refresher in terms of what we covered in our last webinar, but our goal with this project has been to develop this empirical statistical model to predict post-mining water levels within ArcGIS Pro. So that's what I'm going to jump right into and show you guys how it works. So before even getting into Pro, the most important part is setting up the input data from the permits. So the borehole data and well data is used in the prediction within ArcGIS, and part of the download for using this tool includes Excel spreadsheets that have a required format for running within the tool. Some of these required values you can see hopefully on those screenshots on the bottom here as an example of what is required within those sheets. Some of them may require unit conversions from what was actually collected. Within the borehole data, some of that will have to be calculated from percentages of or the total thicknesses of each type of lithology within the overburden. So there is a little bit of calculation required in there, but in general, these values are what would be required within the permit application. The one major exception is precipitation data, and if users don't have a location or a average precipitation for the location of the proposed mine, we did calculate a state average that can be used as a default in this column within the data. And then once everything is entered into those sheets, these sheets within Excel must be saved as comma separated values, the .csv values, so that they can be added to ArcGIS and easily accessed by the tool. So here's an example of the sheets that I'll be using for this tutorial from a mine that was selected from our data set to be an example. So this is just kind of what it would look like then in terms of once everything was entered and then before putting it into ArcGIS, which we'll get to look at here in a little bit. The other required inputs from users specifically is the proposed mine extent. So the extent of the proposed permitted area is a shapefile that will be used within the tools, within the tool itself. While this extent is required for the permit application, a shapefile might have to be separately created if it wasn't created previously. The other required inputs are actually included within the template. You have the shapefile extents of surrounding underground mines that are used in calculating a variable for this prediction. So here shown on the image, it's the pre and post macro mines, which are, as you'll see in Pro here in a little bit, they are the layers downloaded from ODNR's Mine Viewer online. And while these are included in the template, ODNR does update these with new mines. So there may be a need for the user of the tool to re-download and update these layers within the tool package. And the final layer that is required is the digital elevation model, the DEM, of specifically this one included in the model package is specific to Ohio, which for this setup for the model is the farthest extent that wouldn't be usable, but that could also be updated if the user has a different DEM that they would like to use. All right, so the next step is actually downloading the template once you have together your input data. This template can also be downloaded from the same page on Watershed, watersheddata.com. You'll want to save this template into a location on your computer that you can find, such as the same folder that ArcGIS actually stores its own templates would be probably the easiest location to save it to, but mostly just somewhere that you can find it. And then to be able to open this, you actually open it from Pro. So starting up Pro, and as you can see there in this screenshot, you can create a new project from a template there on the right. And that's where you will have this window pop up and be able to find the location of where you saved that template. And then also important is to be creating a new folder to hold this project in, which is that checkbox at the bottom. And that folder is important because it will be used to store some of the data being run within the tool. All right, and then the next step, once you have, it may take a little while for the project to actually open. Once it's open, you'll be able to see the included data files, but then from there you'll have to add your CSV data sheets, as well as the mine extent shapefile for your proposed mine. Those again, you'll have this function at the top circled in the screenshot that will open the file finder so you can find where you saved these, which is where it's important to know where you're saving all your files that will be used in this project. But once you have those selected, you can see the table of contents on the left of the screenshot that will display where they are added. So once you have your data added to the project, there are a couple ways of locating the tool itself, which is included in this package. It's stored within the project toolbox. I will demonstrate this in a little bit as well as to how best to find this and open it. Once you have the tool open, it pops up in the geoprocessing window and has a list of required values that you'll have to work through before actually running the tool. On top there, I have highlighted the required inputs from the user. As we had discussed with the Excels, the CSV sheets, both for the wells and boreholes, as well as the proposed mine extent. But on the very top is the working folder, which will have to be changed to the project folder, the one that was created in opening the template. So the one that has the whole project stored in it would be the best one to have selected for that, for easy access and easily locating where your data ends up. After the required inputs, you have the default inputs, which again are the mine extents of the surrounding underground mines from the ODNR download, which here they are set to the defaults within the project, but if the user has updated these shapes, you're going to have to change that to the shapes that you've added to the map, as well as the DEM. And then the final grouping there at the bottom are the actual outputs of the tool, which it can work if you leave them as those defaults, but the location will be sent to a Scratch geodatabase, which is not, they're not kept there very long and it's not as easy to access. So it's recommended that not only you change the name to something you'll recognize, but to change the location with the folder button there to your either your project geodatabase, which is where the defaults are stored, or to the folder that you've been storing your data in as well. That is the project folder. So again, I'll show this here in a second to be a little more clear with that. And then one more little note on actually running the tool is selecting some projections depending on the data you have. With the Excel sheets, it is required to have the XY coordinates, and to have those, you should know which coordinate system was used in collecting that data, and putting that into the environments tab of the tool itself will help kind of remove any possible projection errors of your data. So the tool can like run with it without this being put in there, but there is a possibility of your points being projected not where your mine is. All right, and so with that, we'll switch over to Pro and I can show you the tool actually running. So this, there we go, everyone can see that, I hope. This is what the project will look like once you have opened the template. I didn't do that part just for the sake of time and having it set up to show everyone today. But this will be what it looks like once the template is opened and you have a new project saved. Here we have added, this here will be the added shapefile of the mine extent that you are looking at examining. Here it's the D21779 that we are looking at, but surrounding that you can see the abandoned underground mines layer in the yellow, and then the blue being the other underground mines layer from ODNR. And then this background here is the digital elevation model as well. And then also in the contents here are the data sheets that have been added as well. They're added into a separate section for standalone tables because these are not displayed within the map until they're created shapefiles from those. So once the data is added to your table of contents here and is on the map, you can find the actual tool that is stored in the toolbox a couple different ways, both from catalog viewing. Here we go. So over here is probably the quickest way to find it. You have your project toolboxes displayed here. So Clicking on that will expand it. And here is your project toolbox then, which is created by the template. And that is where the model itself is stored, as well as the script for applying the algorithm, which you don't have to worry about, but it is there for the model to reference. So this model for predicting points is what you're going to want to open. You can either double click on it or right click for opening the tool. You can also find it by going to the catalog tab up here, which will show you a little more detail in terms of your whole project. So again, here are the toolboxes and your project toolbox. And I'm just double clicking on these. And if you click on these once and highlight them, it will display the descriptions for these, which can also be done by right-clicking and viewing the metadata. But we can also open it from here. All right, and back to the map. So here are the inputs that I was discussing earlier. This is where you're going to have to change this folder to your working folder. It will not work with this default, so this has to be changed. Once you click this folder button, you have your search function pop up here. Sometimes it takes a bit to load. So within your project here, you have your folders, and opening that, you find the actual project folder. And if you open into that, it has all of the other things within your project, but this is the one that you'll want to select for your working folder. And you just hit OK with that highlighted then. Yep, and then it'll change it to that there. These are your Excel sheets then. This one has grabbed the wrong one. It'll automatically try to grab them, but you need to check that it's grabbing the correct ones. So here's the well sheet. This one's for the borehole sheet, which are what are over here. This is the example proposed mine, so that's good there. Grab the correct one. And then these are the default ones from within the template. So these are grabbed correctly, and since I haven't updated them or added new ones, I can just leave those. And then these here are the outputs, which have default names and default to the Scratch geodatabase. But if we want to change this to put into our project geodatabase, we can go here in our project to the databases and go into the project geodatabase. And you can change it to a different file name so you can find it later. So I'm going to change it to the name of the mine that we're looking at. And this was for the well shapes that are going to be output. So outputs projected points for the wells and the boreholes. Yeah, and then this brings it back to where you had just searched, so you don't have to search for it again, but you will want to put in a new name for this. So there's for the points of wells and boreholes, and then this calculated points are the well points with the algorithm applied to them. So it'll actually have that output. Save that in the same location. And then this final one is the same as previous, the calculated points, but with the added calculation of the difference between the DEM and the predicted post-mining water level. So it actually gives you that estimation of difference between the predicted post-mining water level and the surface. So this is probably the one that you'll really want to be looking at. We'll just call it that for now. All right, so all of those are set up. Double check that these are the correct ones, wells, boreholes, and I'm not going to change these now, but if you do need to change the coordinate systems, that's where this is. There's this separate environment tabs from the parameters. But once all of this is input, you simply hit run on the bottom here. And it does take a little while because there is a lot for it to run through. But it does show you what it's running on the bottom, so. I think if you want, you can hit view details and this window will pop open. And you can actually watch as it runs each tool here. This isn't necessary to do, but it is useful for troubleshooting. Yeah, it's those first few steps that take the longest. And this can be just left running. You can work on other things as this goes as well, because it does take its time. This one doesn't show. All right, almost there. And clearing the workspace is the final step. And then it will automatically add all of the outputs to your map so you can see them. And get your little green check mark that it worked. And we can go ahead and close this. And ta-da, here are all of your points. So over here you can see it has created a point shape file for the wells and the boreholes, which were from the sheets that you added on the bottom here. And then these are the calculated points without the comparison to the DEM, but it does have the algorithm. And then finally, the main one we're going to look at is this one where it's the prediction compared to the DEM. All right, and we're going to switch back to the slides here. All right, so we're going to talk about the actual outputs then of this model, which you just saw, and we can go back to the map as well. But if you click on those points, it does pop up with the windows displaying individually what is been input and calculated at that well point. The example here being the one at the top that actually has been calculated to be above the surface elevation. So it'll just be easier if I switch back. So that one is right here. And you can see that the symbology default that I have it outputting in is displaying the ones that are calculated above the surface elevation as red, and the blue ones as below the surface. So if we click on the red one here, it's a little slow. But it does show you, like this is the data from the well sheets, the data grabbed from the nearest borehole, and then the predicted head, which is this value right here. And then the comparison to the DEM is this value to surface. So this one, -9, means that it's roughly calculated as 9 feet above the surface elevation. Oh, yeah.
So one question we just had was about the way that those are labeled, where it says in the legend that red is labeled as below and blue is labeled as above, and that means that the DEM is below the predicted level or the DEM is above the predicted level rather than the other way around. That may be something
Yeah, that might
we
be
switch
something I
the
need to-
wording on. Now that we look at it.
Yeah, you think of it one way and then see it the other way. So
Yeah.
that's a little confusing. That will get changed.
Yeah.
Yeah. But these rest of these ones you can see were not indicating an error except for a couple down here. The other way to look at your results, we'll go back to this. So that was just by clicking on the individual points if you want to look at the ones that are highlighted as an issue, with those two values at the end, the predicted head and the difference to the surface. But you can also open the whole table for your output shapefile, and that will give you the values for each of those points. Again, we'll switch back to that. So here, the way you find the attribute table is by right-clicking on any of these layers, and right here. Screen's a little smaller than my screenshots. Here, we'll go ahead and close the tool. But again, here are all of the points then that were the well points originally, and if you highlight these, it'll highlight it on the map as well. All right, well, you can see him down here on the bottom. It's highlighted. So if you're looking through the table and want to see which one the values correlate with, you can highlight them or double click and it'll zoom to it. But these all have the values at the end for prediction. And here's just an example of an output map that could be created from that.
And one of the
Yeah.
things to see from that is that the areas that are, the areas that are suggesting that there could be a risk of a surface discharge are in the low points on the DEM. And so the results make sense in that way.
Kind of correspond with that. My label makes sense there. So once you have all of those outputs, yeah, so it's displaying where the default is the Scratch geodatabase, but as I showed, you can change that to the actual project geodatabase. And then if you want to use this data outside of ArcGIS to be able to get that table, there's a tool within Arc that is table to Excel. So it'll take that attribute table and you can save it as an Excel sheet to look at outside of ArcGIS as well. So just real quick, a couple of troubleshooting errors. The most common one I would guess would be with the input data at the very beginning. With the way that those sheets are put together, it's very important the way not only that the data is input, but that it is input consistently, and that there are no blanks or zeros or non-numerical values, because that will cause an error within ArcGIS and it won't be able to calculate with that. So it'll just either mess up part of that table or it won't run the tool at all. So if a well or borehole does not have all of those variables required in the table, it cannot be used within this calculation. So just leave it off of these sheets. The way to fix this, like if you get all the way through it and something doesn't work with the tool, I would recommend going right back to those Excel sheets outside of Arc and making sure that the data is consistent and you don't have any of these errors that would be tripping up the tool. And then if you do find those errors or zeros, fixing them within those sheets and then redoing that step of adding that data back into ArcGIS. So you have those fixed sheets in there, and then you can select those for rerunning the tool. The other one I kind of mentioned a little bit earlier too was with the points not projecting correctly. So like if you run your tool and the points are not on top of your proposed mine, there might be an inconsistency with the projection that is defaulted by the tool. Yes, lat long would need to be converted because the default is in XY projections. That is something that would have to be done separately before adding the sheet to ArcGIS, or it can be done within ArcGIS, but then that projection would be, you'd be doing that separately from the tool. You'd be doing that on your own. So it would be better to change it within the sheet itself before putting it into ArcGIS. I hope that made sense. Yeah, so we are going to have other troubleshooting issues within our user's guide and some more details on how to fix these things. But after that, yeah, I'm open for questions. So,
We know that's a little bit of a whistle-stop tour through this, and within the next week or so, the user's guide and the downloadable tool and 2 of the 3 theses developed from this and the recorded webinars will all be available on that website. And we will send a link to that out to everybody that we have emails for. And then once Becca's thesis is done, that will also get uploaded there. But she's defending next week, next Friday. So so that'll be a few weeks before that's up on the website as well. So that's where you'll be able to go and get more information and test things out.
And more step-by-step stuff will be like all of the steps that I went through here will be in the user's guide as well.
Yeah, and once the guy is there, and we will appreciate that people can try the program and send us any observation they have so that we can improve the guidelines. That would be extremely appreciated.
Yeah, it would be helpful to have other people test this as well.
So does anyone have questions? We'll we know it's kind of a lot to digest, but we will. Oh, I've got one. Just a second.
We can go back to Pro as well. So I can't read that from here.
I'm getting. So if the question is if the program is used to assess a mine that's being added to an existing mine for which the program was not used, would the existing portions of the mine be treated as a post-macro mine? So when we did extensions,
yeah,
we've been treating the rest of the mine as a post-macro mine. Yes, that's how it's been treated.
Yeah, so it would be a separate shape.
Yeah, so you would have your new area, your newly permitted area of that same mine be its own shape, and the previously mined part of that would be part of the post-macro mining layer that looks at adjacent mines.
But a lot of those wells and boreholes that were used in the original mine would then be the data for the extension as well.
Yeah, so what Nora just added is that we would also, but a lot of you could use well and borehole data from the original permit, from the original part of the mine, as part of your calculation layer for the next area as well.
Yeah, but if you're just looking at the area of that extension, you're going to want to, and
make sure that you have data that covers that area as well.
Yeah,
Right.
yeah. So you can still use that data. It would just be the rest of the mine would be considered outside of that.
And those post-macro mines are incorporated into that algorithm because we understand that there's a lot of interconnectedness between both the pre and the post-macro mines that are near to whatever mine we're calculating based on. And so that's included in the algorithm to reflect the hydrologic connectedness.
Yeah. Hopefully that answers that.
One thing that to add to that is the more data you have, the less error there is. So in our testing, we are maintaining about a 1 to 1.5% error throughout the whole process. But the more data you have, the less error there is. The better data you have, the less error there is. So Mike just typed, just to double check, the program and other info is available at watersheddata.com. It will be within about the next few days.
Yeah, we were going to use some of the feedback here to finish up the user's guide as well.
Yeah, we wanted to make sure that that what we talked about today was reflected in the user's guide. And so, so we have just a couple of quick changes to make on that, and then all of that will be uploaded to that site, and we'll send a link out to everybody. And that will have the recordings from both of these webinars and the theses that have the theory and the tool and a user's guide. And then
Templates
and then we'll be producing an OSM fact sheet that will also go up there. All right, so Mike asked, in the last webinar, you indicated that specific parameters that had the most influence as well as some parameters that had less influence. Can you refresh my memory on those specific parameters? So the ones that have the most influence are the elevation of the coal and the surface elevation, because that's kind of your geographic bounds. And so those do have the biggest influence, but then after that,
I think after that, the amount of underground mines nearby was another large influence, as
and
well
then
as
the lithology.
it was like the coal extracted and precipitation, but lithology was like one of the lowest. It did still have influence, and that's why we kept it in there, but those values were not as influential.
As the disruption due to mining nearby.
Yeah, and the precipitation and
Amount of mining that had happened.
Amount of
Yeah.
extracted.
amount of coal extracted were like our values for the water being extracted.
And even when the, lithologies and so on, the equation have a lower weight, it is important to note that we need to consider it in order to, decrease the error. In other words,
Yeah.
If we consider more parameters, we are going to have less error in the determination of the elevation of the water. So, even when they have not extremely high impact, they will determine the amount of error that we are going to have.
Yeah, so even though they're not as influential, they're still important to reducing that error.
All right. Currently, ODNR staff are not using ArcPro. We're still using ArcGIS. I do believe we have access to ArcPro through OSM TIPS program. However, everyone wanting to use the tool will need ArcPro installed on their computer, correct?
Currently, yes.
Well, so currently, yes, but then, sorry, I'll let Becca answer this because she can answer this better than I can.
Currently, it's set up to only work on ArcPro, but it can be adapted on to ArcMap. But I don't have that set up yet. mainly because Arc Pro is the one that everybody's moving towards using. So that's the one I wanted to focus on. But I am planning to adapt it into ArcMap as well. So tools do change a little bit between the two, so it's not an easy switch.
If anyone has other questions, we're happy to take them. Oh, Mike's typing, but I'll keep talking while Mike's typing. If anyone is willing to be a tester for us, you can either put your hand up now, or you can drop either Nora or Jen an email. You should have both their email addresses on invitations for these events. And you can either do that using our data or using your own data. And thank you very much, Mike. She shouldn't need too much luck.
Mike.
She's done a great job.
It's an amazing job.
Oh, thanks, guys.
We will stick around for a few more minutes if anyone thinks of questions. Otherwise, thank you so much for being here. And we will send an email out with a link to the project website where you can pull up these, both these webinars and all the other information that we've spoken about.
Once it's all put up.
Yes, once it's all populated, we want to